We are working on the bottom flap of section number 5 in your Unit 3 Quadratic Functions flipbook. In the previous video, we went through the process of learning how to take a graph, a parabola graph, and find out what the function is that actually created that particular graph. And we learned that we can do that for any parabola as long as we can figure out the vertex, and we've got one other point we know is on that parabola. And these were the steps that we went through, class, to actually figure out what that equation was. In this case, we found out that for this parabola, the function f of x was equal to 1/2, that was our a value, times x plus 2, because negative 2 was the x value of our vertex, squared minus 1 because negative 1 was the y value of our vertex. For this video, the essential question is, how do I find a quadratic function from a table? So instead of having a graph, we just have a table of values. And I've written out the steps of how to solve this particular problem. So, step number 1, start with the vertex function form. So I'm going to write that out now. The vertex function form is f of x is equal to a times x minus h squared plus k. There's step 1. Step 2, look at the table and find the one minimum or maximum value of y. Use this point as the vertex. So what you're doing is you're taking a look at the y values and just say them in order and see what's happening with them. We went from 9 to 1, so we went from a 9 to a 1 that goes down the y-axis. Then we got to 0. Then we started to go back up again, back to 1, and then we went to 9. So you can kind of see by just sketching a little line as we're moving between these numbers that this parabola is facing up, and the lowest number on this parabola, the lowest y value in this case, is 0. So if this were upside down, you would have found a highest number. That would have been your maximum. In this case, since the parabola is going to open up, the lowest value of y is our vertex. So here we found that our vertex is right here. So use this point as the vertex, so we can say our vertex based on this table of values is at negative 3, 0. Step number 3, find h and k and substitute into our equation. Well, we know that the h value is the x value of our vertex. The k value is the y value of our vertex. So we're going to rewrite our function. It's now going to be f of x is equal to, we still don't know what a is, but now we know what h is. H is negative 3. Remember, you flip the sign of the h. So when it goes into our equation, it's actually negative or minus negative 3. That turns to a positive 3 squared. And then our k value is 0. Now we can write that on there. Actually, class, you can realize if you're just adding 0, it's not doing anything. So we can drop it off in the next step. So find h and k and substitute in. That's what we did. We substituted the value of h and the value of k. Number 4 says replace x and f of x with a known point from the table. Now, you can't use the vertex for this point, but you can use any other point. And I'm going to tell you, if I had to use negative 6, 9, negative 4, 1, negative 2, 1, or 0, 9, these both look the easier ones for me to use. Look like the easier ones for me to use. Those are smaller numbers, and in fact, I think I'm going to pick this one. You could have picked 0, 9 as well. I'm going to pick negative 2, 1. Doesn't matter which point you use. It'll work no matter what. So we're going to substitute those in for the x value and the f of x value. So our known point that we're going to use, our known point on our parabola is negative 2, 1. We know that the negative 2 is our x value and the 1 is our y value. So when we plug these into our function, we're going to get f of x is going to change to our y value, that's 1, is equal to a, our x value of our known point is negative 2, oops, so it's negative 2 plus 3 squared, and I'm not going to write the plus 0, I don't need to do that, the plus 0 doesn't do anything. Step number 5 now. How did I get step number 5 here? What did I do? Oh, these two steps are the same steps, class. I should have just erased this. Plug in our known point, that was step 4. Plug in our known point is step 4. Okay, so step 5 is going to be solve for a. Well, here's our equation. Remember, PEMDAS, parentheses first. So 1 equals a. Negative 2 plus 3 is positive 1. It's positive 1 squared. I'm going to go ahead and multiply the exponent. PEMDAS, E in PEMDAS is do exponents next. So I'm going to get 1 equals, well, 1 squared is just 1. 1 times 1 is just 1. So that's just 1a. And 1 equals 1a. If I divide both sides by 1, I'm just going to end up getting a equals 1. So right from here, I can already tell 1 times 1 is 1. So a equals 1. We figured out our a value. Step number 6 is write our final function. So now, look again, class. We know what a is. We found out what h is. We know what k is. Hang on a second while I get my cursor back. We found out what k is. So now I can just go back to step number 3 here. I'm going to write the same equation that I wrote in step number 3, only now I'm going to put in my a value. So our final function is going to be f of x is equal to, a is 1. I can write 1. I don't have to, but I'll just go ahead and do that. 1 times x plus 3 squared. And again, I don't have to write the plus 0 on the end. You can do it if you want to, but it doesn't change your equation. So I could actually finalize this by saying, you know what, let's just simplify this one step further. The a value of 1 doesn't change our solution. I can just write that this equation, or this function, is x plus 3 squared. There is our final function. Again, class, if I were to take that function, put a whole bunch of x values in it and find all the y values, I would end up with this exact same table. And if you want to check that out, just plug a few things in. For instance, if you could go ahead and put in negative 4 for the x value, negative 4 plus 3 is negative 1, negative 1 squared is positive 1, out came a y value of 1. So you can see we could test every one of these points now to see if they work. Let's try 0 real quick. We'll plug in an x value of 0. 0 plus 3 is 3. 3 squared is 9. Our output is 9. So perfect. I think we can be confident we found the function that will give us this table of values.